In this next series of videos, we're going to talk about a number of things, but for the first one, we're going to talk a little bit about the basics and the principles of metrology. What is metrology? What does it mean? Why is it important? Also some fundamentals on calibration. We'll use some terms over the series of videos, and there are some key terms we'll talk about now. You'll hear others through the series. So when we talk about metrology, we need to understand that. You'll hear traceability used quite a bit. So we need to understand what traceability is and what it means, and actually, in some cases, what it may not be. We'll talk about calibration. We'll talk about adjustments. You may hear the term verification used. And again, as we go through, we'll have additional terms to that, but those are probably the top 4 or 5 that you need to be aware of. One of the key terms to keep in mind is calibration. And if you think about a definition, and everybody has a slightly different version of this, but when you calibrate something, you're basically making a comparison. So you have a device that I would call an unknown. You don't know what parameter, what value it is. You then compare it to a known device or a known item, and it could be a ruler, it could be a gauge block, it could be a multimeter. And you make that comparison so you can determine what the value of the unknown is or what the error of the unknown is. And that, in a true sense, is what a calibration is. It's determining the property of a device. Calibrations in industry are needed or used for a multitude of things, but the primary requirement that someone would have calibration for a device or for an item is to ensure one of two things: consistency of production or conformity to specifications. So that as you make measurements on your devices or within your processes, you have confidence that the information you're receiving, the product that you are shipping, producing, is consistent and meets the requirements for whatever your end user is or that part of the process. And the calibration enables your tools to keep the consistency to make sure that your output is consistent. Calibration affects a lot of things that we do, but when you look at where calibration becomes very critical, certain industries around the U.S., medical industry, aerospace, have very demanding requirements for calibration and process control. When you think about what's involved as a medical producer for example, medication, to make sure you get consistent dosing, you don't have any issues. If you look at transportation or aerospace, if you're an aircraft manufacturer, you have a very low tolerance for any type of calibration error, again, because of the risk involved of a failure. Failure says that you have components that may not fit correctly, they may come loose or come apart when it's not expected. So you need to be careful during the calibration process that you receive good service and also that you have a good supplier. As we talk about calibration, a calibration event actually will consist of several things. First and foremost, you need to have the device that you're testing and understand what the requirements or characteristics of that device are. So you need to understand what the requirements for test are. At that time, you also need then to identify what standards or references you have to properly test the device. And another key portion of that is traceability, making sure that the devices you're using for test, they themselves are calibrated back to a reference so you know they are consistent. Once you understand what's necessary for the process and for your device you're testing, the next important piece is method. You need to understand that you're using the proper method, tools, and technology to properly value or evaluate a device so that when that device is put into use somewhere, they know that that's working correctly. We mentioned that you need a good supplier. What does a good supplier consist of? Well, a good supplier has a few basic requirements that they have to meet, and these are things that can be identified and verified fairly easily. They need to have a good quality program in place that says that they have process control, they have repeatable processes within the organization so that they have a way to manage their suppliers, They have a way to manage the tools and information used to support your device. They have a way to understand and the technical knowledge to know what your device is supposed to support and operate. Additionally, there are other certifications that can be had externally from various organizations. You could have an ISO 9000 certificate, which is a quality management certification for that. Many labs are accredited to ISO 17025, which is an independent view of their technical skills, operations, and quality. Both of these give an added level of review and assurance that you're using a good quality calibration provider. So what's required to know when to calibrate and what to calibrate? There's a lot of variables to this. It's a difficult question that gets asked. It's difficult to answer in some cases, but it's critical because you have to look at what's the risk of a failure, what's the risk of a nonconformance. So in doing that, most manufacturers will assign, say, a calibration interval of a year, 2 years, 3 years, depending upon the product that they manufacture, and it's based on their knowledge of how the product would operate over time. Those are good recommendations to start with. Again, you have to be able to understand the risk of a failure, the consequences of a failure in order to determine that. But in essence, if you're making measurements, if you're testing to conformity or conformity to process or specifications, calibration in most cases is required. We hear from time to time that people, customers, production areas don't want to calibrate equipment. We hear it's a waste of time, it's a waste of money, things don't fail. And what people don't understand is that there is a cost to maintaining a quality program, a good production system. Agreed, you have to do this, that there's an expenditure involved in this, but the problem comes in is when you don't maintain these systems, don't maintain this equipment, the true cost of quality comes to bear when you have a failure. So the cost for calibration for a single device or for devices in a factory is insignificant when you look at what it takes to actually bring product back from your customers or from the public to say, I'm sorry, I built something, it's not working correctly. It's not only the cost of the rework, but it's the cost of your reputation.